learning in sentiment analysis. Hopes at the end of this national seminar, I takeaway. I welcome you all.
Thank you so much, ma'am. Before we proceed to the first session, we have some general instructions. We request the participants to kindly turn off the camera and mic during the session. Participants, if you have any questions during the presentation, please raise your hand or put them into the chat box. We will bring them up at the end of the session. And also, please fill the feedback form that will be posted in the chat box at the end of every session. The session 1 will be on role of sentimental analysis in health informatics. It will be handled by Dr. R. Kalpana, Professor, Puducherry Technological University, Puducherry. Now I request Mr. J. Manikandan, Assistant Professor CSE, to introduce our vibrant resource person.
A very good morning to one and all present here. It gives me immense pleasure in introducing our resource person, Dr. R. Kalpana, Professor, Puducherry Technological University, Puducherry to the gathering. Dr. R. Kalpana is currently working as professor in Department of Computer Science, Puducherry in Puducherry Technological University. She completed her bachelor degree in computer science from the same university, and she also completed her master degree and PhD in Pondicherry University. Her area of interest includes parallel and distributed and computing, algorithm design and optimization. She has published 94 papers in international conference and journals. Under her guidance, 5 candidates were awarded PhD and 3 candidates are pursuing PhD. She has a teaching experiences of totally 22 years, and she has also received Chartered Management Institute Award in first line management and technical leadership from London. I thank her for providing her gracious presence to join us today. Now I request our resource person, Dr. R. Kalpana, to take over this session. Over to you, ma'am.
Thank you, Manikandan. Very good morning to one and all. I would like to thank the HOD Computer Science and Dr. Jayashree for just making me to just be present in this session. Uh, Let me just go with my presentation. I have planned my presentation in such an order, like. Shall I move on to my presentation?
Yes, ma'am.
Once again.
Yes, ma'am, you may proceed.
Yeah. I think there's a problem in sharing. Is it visible?
Yes, ma'am.
Yes, ma'am.
Thank you. So, very good morning to one and all present here. Today's topic of my presentation is role of sentimental analysis in health informatics. The plan of my presentation just it goes like this. Like I'll be just discussing about what is healthcare informatics and in what way actually the sentimental analysis will be helpful in understanding the healthcare industry and what is meant by sentimental analysis actually, in what way it impacts the health industry, and what are the techniques available for sentimental analysis, and the processes involved in sentimental analysis and the tools available in sentimental analysis. And after that, if time permits, I'll be just discussing on one case study. Actually, 110 data sets, which I have just Twitter data sets, which is actually a synthetic data set which we have taken. So that with that, actually, how the sentiments of the COVID-19 data sets, it was actually accumulated and analyzed, and the results, how it impacts, that is in what way actually machine learning algorithms and deep learning algorithms impacts the results, or that is analyze in a sentimental analysis results. for understanding the COVID-19 data sets, which is actually vaccine related tweets, which we are which we have extracted from directly from Twitter. Okay, so the first one, like first component is like about health care informatics or health informatics. So what is meant by health informatics? The health informatics is nothing but it is a very emerging, and or you can say that the a booming area, whereas actually we can't avoid in our real life. Like some days before, like we can say that automotive industry or automation industry was like it was actually dominating and so on. But healthcare in industry, it is actually a ever demanding industry, and the informatics or the information which is
Ma'am, sorry for interruption, ma'am. Ma'am, we are not able to see your screen, ma'am. I think you have shared your screen.
yes, that's what I'm just first told.
Oh,
Wait 1 second.
okay.
Now,
Yes, ma'am. Now it's fine.
health
Give
informatics.
presentation mode, ma'am. Just give
That's
presentation
what
mode.
that will be a problem again. If I
Oh.
just go for, let me check. Is it
Now,
okay?
yes, ma'am. Now it's fine.
Is it moving? Now, presently, I'm in rule-based approach. Is it
Yes, ma'am.
moving?
Now it's fine, ma'am. You
Yeah.
can
Okay.
proceed.
Okay. So this health industry, health informatics, it connects people, technology, and data to better improve healthcare outcomes. And with that, actually, we can just find supporting operational and technological and advancements like worldwide. So some of the examples include patient portals, electronic media, medical records, telehealth, healthcare apps, and there are so many other data reporting tools which is actually related to health informatics. And next one, what is the need for health informatics? There are why do we just go for an the information processing systems? Because it drives operational efficiencies which enable streamlined comprehensive care and protection of patient data. And it covers health data collection, storage, extraction, manipulation, reporting, and communications through technologies like wearables, apps, and telehealth. And there are so many other web apps and mobile apps which are actually working for this type of various features. And it also includes design, configuration, and management of health information and clinical support systems. And what is sentimental analysis? Why it is required for a healthcare industry or health informatics? So it is nothing but a generally sentimental analysis is nothing but it's a contextual text mining which identifies and extracts subjective information in source materials. Subjective information means like which is actually required and which is actually on demand or which actually impacts something like the societal development, or like there may be n number of applications which is actually behind that. So it is actually related to the subject which we are talking or speaking. Okay, so this is nothing but this sentimental analysis. It's nothing but amalgam of statistics, machine learning, and natural language processing, which is to identify and extract subjective information from the text files. So it can be a customer judgment, opinion, feelings, thoughts, or assessment about a particular product, brand, topic, or even it can be anything. Okay. Now, what are the techniques available for sentimental analysis? So there are many techniques available. So among that, we are just going to just what is actually widely helpful for analyzing. Natural language processing, machine learning, deep learning and transfer learning, text mining approaches, and information theory and coding approaches, semantic approaches, and also hybrid approaches. Among this hybrid approach, it is considered to be the best one when compared to all others. And just the different strategies, or I can say that the classification diagram or taxonomy of the models, techniques, which is actually available for sentiment analysis, I have just given a diagram of that one. And how this sentimental analysis will work or will be helpful for understanding or human, that is customer opinion or customer feedbacks, anything. So it is otherwise also called as opinion mining, which works with the natural language processing and machine learning algorithms to automatically determine the emotional tone behind online conversation. So again, there are different algorithms which are available and tools are available to just implement the sentimental analysis models, depending on how much data you need to analyze and how accurate you need your model to be. So based on which we can just categorize. So there are three categories just with which actually we can just classify. Which is first one is rule based. What is meant by rule based? It is nothing but we'll be just interested in system which automatically perform sentimental analysis based on a set of manually crafted rules. So that means the rules will be just it is actually framed by the technical person, and based on which actually it will be just automatically performing the operation. The next one is automatic systems, which is actually based on the machine learning techniques, and with which actually we can just learn from the data, so that machine learning algorithms will be applied, the system will be developed. And the hybrid of this one is nothing but it is actually both rule based and automatic approaches. And what is meant by first rule based? Rule based system, like which is actually a convenient model, or you can say that which is actually which uses a set of human crafted rules to help identify subjectivity, polarity, or the subject of an opinion. So these rules again include NLP techniques developed in computational linguistics, like stemming, tokenization, part of speech tagging, parsing, etc. So it also uses actually lexicons or list of words or some of the expressions like that. So some of the examples like how actually a rule-based system works. So let's take an example of, we have two lists of polarized words. So one is nothing but negative words such as which uses bad, worst, ugly, and so on. Positive words such as good, best, beautiful, which we are using. And this counts the number of positive and negative words which appear in a given text. If the number of positive word appearances is greater than the number of negative word appearances, the system returns a positive sentiment. Again, it is a vice versa. The negative word appearance is more, then it will be the system returns a negative sentiment. Okay, and if it is neutral, it is nothing but if it is even, that means it is actually it will be giving a neutral sentiment. So this rule-based system, it is actually very nice, and which will not be taking into account how words are combined in a sequence. Okay, and that means it is not actually defining any relationships. The next one is automatic approaches. So this rely on the manually, definitely it is not relying on the manually crafted rules, and it is actually based on the machine learning techniques which are available. Okay, so a sentiment analysis task is usually modeled as a classification problem, where actually there is actually a set of classifiers available. So it will be fed with the text and it returns a category, whether it can be a positive, negative, or neutral. Okay, so there are some ways actually with which actually machine learning algorithms implemented. So we'll be having a training model and testing model, or training or prediction models, where actually text will be just given to the feature extractor will be just extracting the features from the text, given text, and it will be applied to the machine learning algorithm, where actually classifier will be helping for, that is classification. A set of data will be trained. It will be trained, pre-trained, and the prediction will be based, like it will be working on with the set of trained data sets with which actually it will be the new predictions will be newly entered data will be the features will be identified, and it will be just based on the training data sets, it will be classified appropriately. Either it may be positive, neutral, or negative. And automatic approaches, like that's what this particular the training process, like it will be just associating with a particular input and a corresponding output. So the input is nothing but a text, and the output is a tag. So based on the test sample used for training. Okay, the feature extractor, it transfers the text into a feature vector, and here we have pairs of feature vectors and tags. It can be the tags will be positive, negative, and neutral, and it will be fed into the machine learning algorithm to generate a model. So in the prediction process, the feature extractor is used to transform the unseen text inputs into feature vectors. So again, this feature vectors will be fed into the model, which generates a predicted tags that can be positive, negative, or neutral. So the feature extraction from the text, so that is nothing but here the machine learning text classifier is just adopted to transform the text extraction or text vectorization, and the classical approach has been, it will be definitely, that is a bag of words will be used, or bag of engrams with their frequency. And it is actually the new feature extraction techniques have been applied based on the word embeddings. Okay, so this kind of representation makes it possible for words with similar meanings to have a similar representation. So because this improves the classification performance will be improved because of this. And the classification algorithm, so there are many classification algorithms. Like we have the statistical models, which uses Naive-Bayes algorithm, logistic regression, support vector machine, and also neural networks. Now here, actually, the Naive-Bayes is nothing but which uses a family of probabilistic algorithm, which uses Bayes theorem to predict the category of text. And linear regression model, it is actually a well-known algorithm to predict some of the, that is output value y based on the set of features x. And support vector machine, it is nothing but it's a non-probabilistic model which uses representation of a text example as points in a multidimensional space. Examples of different categories, now sentiments, are mapped to different regions within the space. So the new texts are assigned a category based on the similarities with the existing text. So there will be a group of text available. So with that group, it will be that is newly entering text will be matched or mapped to the already existing models. Okay, and the neural network model, like which will be having the multiple layers of neurons, which will be working together to generate a newer model. So that is actually, and again, an impact that follows, or I can say that deep learning follows that one. And as a deep learning uses a diverse set of algorithms which attempts to mimic the human brain by employing artificial neural networks to process the data. Hybrid approaches, again, it is nothing but it's a combination. So the desirable elements of rule-based and automatic techniques will be just put into one system, and it has actually very good results, and the results are comparatively very accurate. Okay, the next one is the processes which are involved in sentimental analysis. So first one is data collection, next one data pre-processing, data analysis, data visualization. So these four steps, which are very much actually, or you can say that every step is actually, it has actually or I can say that a drastic impact in the results of the suppose take an example. You may feel that data collection, we have something like in present in Kaggle or some other website. Okay, but what we need to first of all understand what is actually that particular data, and we need to extract the features appropriately. There may be there are always will not be having the 100% data completely available. So we need to just properly pre-process. So first one is a data collection process. This is one of the important steps, and this actually all mainly everything depends on the quality of the data which has been gathered and how it has been annotated or labeled. Because this quality of data, that is actually very important component. Uh, if I just collect, if I just do some 100 data samples, I'll be just completely filling all the columns. But whatever the real-time data, whichever I'm extracting from the web, it need not be. Okay, that is actually lag in the quality. Okay, so for the different categories or API data, so which can be uploaded through live APIs for social media. So suppose like an example of like a news API, which can help you glean information from all kinds of news publishers, while a Facebook API can allow you to take all the publicly available data you need from its platform. So there are so many repositories available: Kaggle, Amazon reviews, Yelp, and so there are which are available. So from where we can just collect according to the needs of the our need, we can just collect the data. So manual data. Suppose take an example. I want healthcare data from a particular hospital. I want from JIPMER. Okay, I can also collect it. Okay, so there are tools used available for that to just to just collect appropriately the data to my need. I can just do it. So we can just upload it, and we can just that will be helpful. That is for others to understand and analyze the system. I may be working for a machine learning algorithm. Some other user may be interested in deep learning algorithm for the same data set. Okay, so it will be just generated in the form of a .csv file. Okay, the next one is data pre-processing. So here the raw text data, which will be containing unwanted or unimportant text, due to which our results might not give efficient accuracy, might it will be just we can just erase that, or we can just we need to avoid that. So proper pre-processing must be done on raw data. So the pre-processing steps involves data quality assessment, data cleaning, data transformation, and data reduction. So first one is quality assessment. Okay, suppose take an example. You take a you have a data and you get an idea of its overall quality relevance, which is actually relevant to your project and consistency. So there are number of data anomalies and inherent problems which is actually present in the data set. Okay, so the mismatched data types. Once again. The mismatched data types. When you collect data from many different sources, it may come to you in a different format. So it's something like some may be in Word format. Let us take an example, Excel format. So yeah, but you need to just process the in your machine like it will be just reformatted. That is one single format we need to reformat, and yeah, that is which is actually the you'll still need just begin with similarly formatted data you'll be identifying, and first you'll be doing that one. So, okay, if example, if part of your analysis involves family income from different multiple countries, you will have to convert. Suppose taken father is working in Chennai and son is working in US and other daughter is working in Australia. The currencies need to be just it has to be converted to a single currency so that you will get a family income. Okay, and next one is mixed data values. So there are different sources which use different descriptors for features. So I may be using and sometimes like will be just gender will be using man or somebody may be using male. Okay, but you need to follow some universal or you can get a uniformity in just giving the values or labeling. Okay, the next one is data outliers which can have huge impact on the analysis. For example, when you're averaging test scores in a for a class, so one student he might not have responded to any of the question, so that zero value that person student gets it has actually impact, or somebody is absent, so that will be having an impact in the result. So when you do an average or when you do some operation data analysis part you're doing, that will be having an impact. And next one is missing data. Take a like when you are just taking a row, a particular data record, so there may be some missing data available, blank spaces available, unanswered survey questions will be there. So because of this is because of the human error or incomplete filling of data. So those things we need to just do a cleaning process. So that is actually data cleaning. So it is a process of adding missing data and correcting, repairing, or removing incorrect or irrelevant data from the data set. So this is one of the important step in pre-processing because it ensures your data is ready to go for processing or for the needs of the that is downstream needs. We can just do it. Okay. So this process will correct all the inconsistent data you uncovered in your data quality assessment. Okay. So then what is actually how actually the missing data will be just cleansed. Okay, there are different ways of correcting the missing data. So first one is ignore the tuples, and the second one is manually fill in missing data. Ignore the tuple means suppose technically there are actually a sequence of numbers or entities which are available. A tuple consists of that. If multiple values missing within the tuples, then you can discard that tuple itself or that row itself. This is applicable whenever, or this is recommended for only large data sets. You can remove the tuple itself or remove the record itself. That means it will not have any impact in the results. That's what we are going to conclude. And manually filling the missing data. So sometimes like you may be knowing that is this data, it should be like this. Okay. So this person, he'll be, that is the average income. If we say that average income is this much. So this person, if he is working in this particular organization, we can able to just manually fill that is he'll be having of salary within this range. Okay. The next one in data cleaning, again, noisy data will be there. Okay. So we need to fix up the noisy data. That means this is the data which includes unnecessary data points, irrelevant data, and which is more difficult for just grouping. So take an example of binning. Binning sorts data of a wide data set into smaller groups of similar data. So this is actually helpful for analyzing demographics. For example, when you group, when you have salary ranging different ranges we can just group into a single smaller group of like $35,000 to $50,000 in a single group. and $50,000 to 75,000 in another group. Okay, regression, so which is actually used to decide which variables will actually apply to your analysis. Okay, so it will be having large amounts of data. You can handle your data, and you, if you are, that is, if you are not overburdened with unnecessary data, just we can, that is, whenever it is required, we can have. Whenever it is not required, we can just do that. Okay, and the clustering model, it is actually used for properly grouping the data, and the so this grouping, again, it is actually based on the relationships which exist between the data. And other part of data cleaning also includes that is some cleaning which is actually related to removing of URLs, symbols, emojis which are not relevant to the analysis, and translate all text into a single language. Suppose take your Twitter itself, like we have Tamil comment may be there, English comment may be there. So we need to convert it to a single language. So for which we are working, and remove HTML tags and boilerplate email text which is actually not relevant, and remove unnecessary blank text between words, remove duplicate data. And after the cleaning process, you can realize easily that there are so many insufficient, that is you may have insufficient data for task at hand, but at one point you can just definitely conclude that the data which is required for the analysis you have accumulated. And the transformation process, so like whenever it just go for the transformation process, you are just turning the data into a proper format, so which is actually required for your analysis. So there are different transformation approaches: aggregation, normalization, feature selection, discretization, concept hierarchy generation, and so on. So first of all, aggregation, which combines all of your data together in a uniform format. And the next one is normalization. Normalization, it scales your data into a regularized range so that you can compare it more accurately. For example, if when you're comparing the loss or gain in a particular organization, so within for a particular employee in a with comparing with many companies. Okay, so assuming that is, you can scale them within the specific range, either -1 to +1 or 0 to 1. Okay, this is actually which will have a regularized range. And feature extraction is a process of deciding which variables is actually most important for your analysis. The features will be used to train the machine learning models. The more features you use, like there will not be, that is a longer training process will be there. Sometimes it will be producing the less accurate results. Okay, and here the feature selection model, like we have actually different categories: unsupervised, unsupervised. Like unsupervised, we have actually pattern recognition algorithm. Supervised model, we have actually topic tagging, characteristic tagging, and sentiment tagging. Okay, discretization, which is nothing but which pulls data into smaller intervals. Somewhat similar to binning process only, but take an example of whenever you're calculating average daily exercise. So rather than going for minute by minute what we are doing and what is actually how much time we are just taking to do that exercise, we can just put it in a smaller groups, 0 to 15 minutes, which will be falling. That is one category, and 15 to 30 minutes another category. The next one is concept hierarchy generation. This will be adding a hierarchy within and between your features. Okay, and which is not present in the original data. And data reduction, so this is also one of the important step. So like when you just do the analysis, even after cleaning and transforming, like you need to work on that one. Okay, so depending on the task what is required, so when you are working with the text analysis, your regular human speech is actually it is superfluous in nature, and many things are irrelevant to the needs of the researcher. So in that case, we are forced to go for reduction. Okay, and it makes actually analysis easier and more accurate. But the data storage will be just cut down, and you will be having a lot of cut down will be there in the data available data. So, and it can also it will be helping in identifying the important features. The next first one is actually this data reduction. There are different models available. So first one is attribute selection. So similar to discretization, attribute selection can fit your data into smaller pools. it combines tags or features, so that like if I say that male or female, there is one tag, and professor it's another tag. Okay, now we can just combine together male professor or female professor. We can have it as a single attribute. And numerosity reduction, so here it is used to only, that is the you can use a regression model, like whenever, just for example, we can use only the data and variable which are relevant to the analysis can be adopted. And dimensionality reduction, which reduces the amount of data used to help facilitate analysis and downstream process. Okay, there are many algorithms which is actually helpful for this one. And data analysis, which is actually third step in sentimental analysis. So that data analysis part includes actually training the model. So suppose I have will be applying 80 to 80-20 rule. 80% of the data will be just using for training. Okay, so the data set actually will be helpful, will be used to train the model. So we'll be just getting all the data which is actually labeled. So we can just find out the classified data, and which will be helpful for predicting the new models. And here we have another data analysis model, which is nothing but multilingual model. So in the case of sentimental analysis, the steps which include multilingual data processing or requisite IQ, which has data set for each language individually annotated and trained. So this is because the platform doesn't rely on translations at all, since all the information can get distorted and nuances lost due to vast differences in certain languages like Spanish, Korean, and so on. So it is actually Repostate gives the highest accuracy scores compared to other platforms. And we have customer tags. So in this part of the process, customer tags for aspects and themes will be created for different brands and products. Okay, data analysis, like here again in this data analysis we have another interesting component, which is nothing but topic classification. This is actually attaching a theme to a text. For example, I have the dresses are awesome and I found some really good scarces as well. So this will be tagged as a topic clothes. Okay, so the complete sentence will be, it will be just actually it is coming under topic clothes. Okay, I give an example text, that is the dresses are were awesome and I found some really good skirts as well. So this will be coming under a topic clothes. And the next one is sentimental analysis. Each aspect and theme is isolated in this stage by the platform and then analyzed for the sentiment. Again, the sentiment scores will be given. It will be ranging from -1 to +1. A neutral statement or neutral sentiment will be 0. So assigning of polarity is important, which is because even platform, that is, we can assign different scores to different aspects like convenience, speed, cleanliness, functionality, drinks, ambience, and for patient care, everything we can just give different scores. So the aggregate scores, it will be calculated to know the sentiment of the audience towards the brand. So let's take an example. If 3 of the 7 aspects receive poor rating, which is nothing but -0.65, and 4 of them receive good ones, it will be +0.5. The sentimental analysis gives the average score as the overall sentiment of the brand. Okay. The next one, the last step, that is nothing but data visualization. So which is actually the important, or I can say that which actually gives a clear picture of the sentiments of the user. So once all the steps are completed, so the insights are like it will be just it will be forming an actionable report in the form of graphs or charts. So this chart or graph will be shared with the team. So the visual reports are very, very important because it gives actually, you can see at a different granularity level, and we can get aspect based results. So take an example, when you get an average score for your brand, you can filter the results in the sentiment analysis dashboard to see which aspects got how high a score and which one got low scores. So with that, actually, if it is actually product company, so we can just make changes wherever which feature actually just actually impacting or the brand, the product actually the results of the product. So that we can concentrate, that feature we can concentrate, that area we can concentrate, so that the results will be better. Okay. And there are so many tools again available for analyzing the sentiments. Okay, so which is nothing but the tool is nothing but it's a software which analyzes text conversation and evaluates the tone, intent, and emotion behind each message. Okay, so when you have so definitely when you have a tool which uncovers more context from your conversation and helps your customer service team accurately analyze the result, that will be definitely helpful for the business users. Okay, so this is particularly useful for brands which actively engage with their customers on social media, live chat, and email, where it can be difficult to determine the sentiment behind a message. So these are different tools available. That is Avario, Quick Search, Repustate, Lexac, Lexalytics, NCSU Tweet Sentiment Visualization App, Brandwatch. So let me just give some small introduction about each tool, in for which category it will be helpful or which application it will be that is more suitable. So it is actually Avario is a social media monitoring and analysis tool. This covers all major social media networks, news, blogs, forums on the web. So this has actually inbuilt sentiment analysis feature, and it sorts brand mentions like the different results, classified results will be positive, negative, neutral. Okay, so we'll get a graph which shows how your mentions have grown over time and how their overall sentiment has changed. So, in addition to the brand sentiment, you can also see the topics which get mentioned most often when people speak out your company. So, whichever that is the company we are going to use, like for which actually the brand which is may commonly used, that will be also that will be coming as a result of this sentiment. And quick search, it's a sentiment analysis tool, so that's like where actually which is applicable applied in a large customer service platforms. Okay, this particular tool, it will be best with your social, with the social media channels, because it can tell you exactly how people feel about the company's social media accounts. Yeah, and this one gives the mentions, comments, engagements, and the data which is actually relevant to the team. And it will be giving an extensive breakdown of how the customers are responding to the social media and the activities related to social media. Okay, and which will be helpful for the that is for the working team to produce or to plan and produce effective campaigns which will just captivate the target audience, the results of the target audience. The Repustate, which I told already, which is actually a sophisticated text analysis API, which accurately assesses the sentiment behind customer responses. Okay, so like take an example, like we have a short-term text like LOL, ROFL, which is actually commonly used in all the social media. So it will be just taking, and also it will also analyze the emojis, and the it will be just determine the intention behind the context of a message. Let's take an example. If this emoji is used, okay, Repustate tells like whether it's a positive symbol or a negative symbol, and based on that is the following statement, the rest of the conversation it will take, and with that actually it will be just concluding positive or negative symbol. And Texaltics, it's actually a text analysis tool which is focused on explaining why a customer is responding to a particular business in a certain way. Or something like if he's telling that bad about the business, like usually we'll be giving feedbacks in Swiggy's. Something like a delivery person a problem, like that we are just telling. Okay. So whatever the text information we are giving, so that will be just it has a larger impact in the business model. So that will be analyzed. This text analytics, so text analytics is a one tool which is actually helpful for this. So this is actually it uses natural language processing to pass the text, and it runs a sentiment analysis to determine the intent behind the customer's message. Okay, there may be some customer, or there may be sometimes like company person itself, they'll be giving the customer message to boost the delivery. Suppose take a delivery person, like to boost himself, like he can just give a he can mimic the message with the help of his friends or something like that. He can just do that. So his service can be like this is actually the intention behind the message will be just deliberately just retrieved. Texaltics again, it concludes the process by compiling the information, and it drives into easy to read and shareable display. And the next another one tool that is it's a visualization app NCSU, which is actually exclusively used for tweet data sets. The Twitter data, it has actually highly indicative of broader brand reputation on the social media, because actually all the politician that is all cinema industry, everybody is behind this Twitter data. All are Twitter users, and this Twitter data, it plays a very important role in sentiment analysis. Okay, and this is an online solution provider, the Sentimental visualization tool. It will analyze the data and showing the results of both sentiment and topic analysis. Like today, I may be discussing one topic. Okay, today I may be discussing the parliament issues. Tomorrow I may be discussing cricket. So it will be just producing visualization results based on that. And brand watch is actually one of the, it has actually this is one tool which uses image insights. Okay, the images will be associated with that. So whenever you upload an image of your brand's logo, the brand watch serves the web for images which has actually include this logo, and it compiles the images into a single particular topic, and it highlights exactly where your brand's logo is appearing. Okay, and the next one is like as I told earlier, that is this is nothing but a case study. Okay, now I'm just going to show like the Twitter data set which we have taken, uh, which is very small, 110 data sets. Okay, so with that actually we are just going to see how it is performing. Okay, how sentiment analysis quantifies the performance in the case of health industry. So in sentimental analysis in healthcare, which allows providers to classify patients' comments into components. Okay, so it can be a component means like it can be about talking about a people, that is nurses or physicians or places or processes and so on. So the scoring of comments, whether the scoring comments or we can just categorize whether it is positive, negative, so that which has actually impact on the hospital's revenue or hospitals yes business model. It can just quantify patient's experience and identify where actually improvement is required. Some of the useful examples the comments by the patients or like helpful and caring nurses. They responded to my healthcare needs with care and urgency. This is a positive comment. And the next one is excellent customer care, but appointments need to be automated. It's a neutral comment. And third one is I sat for hours on hold waiting to talk to a receptionist. This is a totally negative comment. So I gave an example for three different comments. Okay, so this text, it has to be, we need to understand first of all this text, what it means. The second one, excellent customer care. First one, if I read, I'll be just telling that's a positive comment. But the rest of the portion, but appointments need to be automated. That concludes that's a negative comment. So when you combine this one, it should be concluded as a neutral comment. Okay, so Twitter is actually we know very well it's a microblogging platform and a social networking services which generates a vast amount of information. Okay, and here with this sentiment analysis on that is by applying natural language processing, we can just get a positive, negative, or a neutral comment. Okay, so we are just going to take the Twitter data sets and the machine learning algorithms and the deep learning algorithm. So let us take an example of that is COVID-19, the tweets. Okay, and we are going to apply that is whatever we have the machine learning algorithm is adopted here with that particular COVID-19 data sets. Okay, the results we'll see. So the detecting sentiments of the particular user, Twitter user, and that to identify that one, machine learning is applied. So it has actually a training model which uses like specific features, and after that testing data it's actually we have taken. Okay, 80% of the data is actually used for training and 20% is used for testing the data. And the models, different algorithm machine learning models are adopted are support vector regression, decision tree, random forest, multinomial logistic regression. That's actually softmax. So the overall accuracy obtained, which is actually a tenfold cross validation, that means multiple validation models are available, and each of the classifier is used for the one particular validation. And with that, actually, we'll be just coming out with a classification. So the accuracy obtained in SPR is 22.39, and random forest is 35.71, decision tree is 28.57, softmax is 57.57. So the overall architecture of ML algorithm, machine learning algorithm, is nothing but will be having the will be collected data collection will be from the Twitter data set. Okay, and it is actually put in a repository or a database. And here the cleaning process, or you can say that data pre-processing will be made, where actually we'll be just doing hash and the special at symbols, URLs, and stop words will be removed. Tokenization will be made, stemming, case conversion operation will be made, and after that, actually, the learning algorithm model, that is feature extraction, will be made, and scoring models will be done, and data will be trained and tested. Like the second phase will be tested. So the classifier, corresponding classifier will be used, and we'll be getting the classified data. Yeah. So this particular input data set, actually it is nothing but COVID-19 vaccine related tweets. Okay. And the next machine learning, next one is the machine learning technique which is adopted. The support vector regression. It's nothing but it is a supervised learning model which actually does the classification, regression, and also outliers which are helpful for statistical theory and learning. So here actually we have actually a different classification we'll be getting. So this one is for vectors, and which is this is actually another classified model. Okay, and decision tree models. This is actually non-parametrically supervised learning model, and this uses it is commonly used for task classification and task regression. Take an example. We have actually one classification model, bad rating. So it can be a negative, neutral, positive. For a negative, we have bad, toilet. These are all some of the example. Okay, then positive, effective start. Okay, for neutral, detective, story. So these are all some examples of words which is actually used. The next one is random forest. It's a technique used for classification and regression based on the ensemble method. And here, this is based on the bagging of bootstraps. But that's nothing but like we have actually a sample data which is actually available, which is actually if there will be many hierarchies available, we'll be having a collection of trees with which actually different prediction results will be coming out, and these predicted results will be just average. All the predicted results will be average, and a common prediction will be performed. Okay, the next one is softmax model, which uses actually a vector of k real values. Okay, and this has actually the range which is from 0 to 1, which is actually more relevant or more equivalently to that of probability model. So everything will be mapped from 0 to 1. Okay, and this is the result of a machine learning model. Softmax, it gives a better accuracy, 57.57. Okay, compared to that of decision tree, support vector, and random forest. Okay. So next one is the same data set when it is used with a deep learning model. Okay. So we can able to get an idea that is actually it provides low accuracy. ML provides a low accuracy with respect to this particular data, COVID vaccine related tweets. Okay. So to solve this problem, we are just going for a hybrid approach, which involves actually a sentiment analysis using a supervised deep learning model, such as multi-layer, long, short-term memory networks, and word embeddings. So these two things are combined. It's actually considered to be a hybrid model. Okay. So we can get positive, negative, and neutral comments, which is actually for the Twitter data sets. Okay. So the output of the sentiment could be identified from feedbacks and comments, and this will be providing better accuracy, and also it identifies failures and duplicate content which is available. Okay, so this deep learning algorithms, it will be providing sarcasm detection. That means like where we have actually voluminous multi-sources data, so that actually time taken for analyzing this large amount of data could be reduced because of this deep learning models. Why it is so? Like we'll see that. Okay. Like we have actually this particular deep learning model, it uses actually word embedding plus LSTM. LSTM is nothing but a long short-term memory network. What it means actually. In the case of RNN model, like so anyhow we'll be seeing that. We'll be having a memory will be there, but it will not be like I have a lengthy sentence. Take an example, I have a very lengthy sentence. It will be having a short memory will be there. Okay, only at, or you can say that in RNN we'll be having the last used words like that. Okay, but this long short term will be giving a better short term memory, so that what will happen, we'll be getting a sequence data. Okay, so having a memory in the network will be very helpful, because when dealing with the sequence data, like a text one, the meaning of the word depends on the context of the previous text. It is actually because the earlier one also neutral statement, because when you see the first sentence, you see that one as a positive case, whereas the rest of the sentence, when you see, like you can say that there is some negativity behind that also. So the entire statement only decides. So that means the previous statement, which is actually the knowledge of previous statement, is very much required. So because of that, actually, this is actually the model which uses actually access the input, and y is the output, which is the output coming out. Hi is nothing but ht is nothing but the hidden state. Okay, there are maybe many hidden state which will be available. Okay, and how the deep learning algorithm will be working. So the word embeddings are basically a form of word representation which bridges the human understanding of a language to that of a machine. Okay, it is actually a distributed representation of text in a n-dimensional space. Like take an example, you have as a different space, like where actually king is mapped with the queen, man is mapped with the women. Okay, and also like here this is male and female, whereas here this is actually verb and a word, walking and walked, swimming, swam. Now country to capital, how it is mapped: Spain, Madrid. So like let's take an example: China, Beijing, Turkey, Ankara. So this is nothing but how it should be distributed, how it should be embedded. The word should be embedded or mapped, and how the deep learning algorithms like or works better. So we have actually global vectors. So GLOVE is actually an unsupervised learning algorithm for obtaining vector representation of words. Okay, so training is performed on aggregated global word-to-word co-occurrence statistics from a corpus. So this GLOVE learns vectors or words from their co-occurrence information, how frequently they appear together in large text corpora. Take an example: the sun rises in the east. The how many times it is used, that is nothing but the frequency with which actually it is used in the corpora. So the text corpora, it may be very voluminous in nature, or large or small, can be, depends on the application word what we use. So this GLOVE is actually the training model is very fast, and it is scalable to huge corpora, and it provides good performance even with small corpus and small vectors. Also, it outperforms the other models, like which is based on word analogy and word similarity. So the deep learning algorithm, in what way it is actually, how it is actually used. So we'll be having a data set which is actually extracted from CSV file. We'll be doing the pre-processing, that is same process: removal of special characters, tokenization, stop word removals, and stemming. The feature extraction module will be next one, and the next one word embedding will be done, and after that classification, which is based on RNN, recurrent neural networks, using LSTM. Okay, and after that it will be evaluated, and the classified result will be getting for better accuracy. Okay, this is the flow, the three data sets whatever we are taking, and after the data pre-processing will be done, and next one tokenization, and we'll be just getting the that is the reviews will be collected based on, it will be analyzed for length, and if it is whichever is required, it will be truncated, and it is not required, that will be truncated. And next one, the word embedding will be made, and RNN based, that is LSTM based RNN model will be just worked, and the network will be trained for various classification models, and accordingly it will be tested for positive, negative, and neutral sentiments. And the let us take, that is whenever we just go with LSTM model, the problem aims to explore the sentiments related to COVID-19 vaccine tweets. Okay, so we have 5 different classifications: highly positive tweets, moderately positive tweets, highly negative tweets, moderately negative tweets, neutral tweets. These are 5 important classes of that is classifications. Okay. So now take an example like whatever the algorithm classification model we are using and globing, we'll be just using the word embedding and we'll be using multiple LSTM models, multiple layers, so that it will be the pre-trained model will be working accordingly. So not only pre-trained models, like after that actually it will be having a long-term short memory. With that actually the pre-trained model will be effectively applied for better understanding or better analysis. Okay. So and here this embedding the embedding layer, word embedding layer will do a word embedding for all the words in the data set. So RNN or networks which are used for things that happen recurrently, so that like one thing after whatever is happening, that is it can be words or it can be time series. So this LSTM, it's nothing but it's a specific type of RNN, or you can say that extended version of RNN, which are capable of learning the relationships between elements in a input sequence. Okay. So here, whatever we use, is nothing but a text information or words. Okay, LSTM networks, it maintains a state, and it will be just the problem of that is the whatever problem we get in the normal RNN will not be coming here, because it uses a long-term long short-term memory. Okay, so using the multiple layers in LSTM with activation function for each layer, the output can be improved. The better accuracy will be getting. Now coming to this one, this is actually the input. COVID vaccine related tweets extracted from Twitter available. That is from GitHub. It has been extracted. So the first one is, by the time you idiots release it, the damage is already being done. So I'm just telling this is COVID vaccine related tweet. Okay, already 60% have antibodies in the country. So this is the first tweet. Next one, I'm a little skeptical about this vaccine. Third one, congratulations at Bharat Biotech, but we thought you were already in human trials. How does this now on animal trial make a difference? It has been a it has been great to hear some positive news in the world over the past few days. Fifth one, amazing to see world's medical and scientific communities coming together for a COVID vaccine. I hope the tweets, the data set, whatever I have taken, the different ways actually, whatever we have, different classes of input data sets, whatever we have taken, it will be, I think I've been able to understand. Okay. Any doubt as of now? Any doubt?
No, ma'am. No, ma'am. You can go ahead.
Yeah. Okay. So now see this one. I think this particular slide definitely it will be helpful. So we want to classify now. Okay. So zero means it is highly negative, and the next one highly moderately negative, and the third one is neutral, and fourth one is moderately positive, and fifth one is highly positive. Okay. So take an example of highly negative word. So which has actually the scoring is 0. So by the time you idiots release it, the damage is already being done. That means it's a totally negative comment. And something like moderately negative means I'm a little skeptical about this vaccine, so that he can't do anything. That is, he's actually having a negative feeling, but he's just he's accepting that. And the neutral comment, it is actually it is congratulations. Okay, the person is appreciating. The tweet appreciates person. Sorry, the product, that is a vaccine. But actually, already the human trial is going on. So that means there is some negativity at the end of the statement. And the fourth classification is moderately positive. Okay, moderately positive means like somebody is telling that some tweet is just confirming that there is some positive news, but we are not sure whether it is a positive result or not. So that is moderately positive. Then fifth classification is amazing. Amazing means like it is nothing but appreciating the efforts of the scientific community. Okay, so this is actually again a typical tweet. So now the classification, I assume that it will be clear to all. Okay, now the thing is like we have different that is we have already machine learning algorithm which was applied. Now the deep learning algorithm, when it is actually the different activation function, the results are just given here. 77.27, which is actually with the softmax we have got. And comparing two algorithms, that is machine learning and deep learning algorithm, the accuracy is comparatively better in deep learning, 77.27 and 57.57 in the case of machine learning for the same softmax. Okay, in the conclusion, before concluding, let me just tell you the data set what I have taken. Is it visible? Excel sheet is visible.
Ah, yes, madam. Yes.
Okay, so now, so this is actually the tweets which actually we have taken. Uh, the for the tweets related to COVID vaccine. Okay, so what Haryana Health Minister, something like that. This is actually moderately positive. So we have just classified that, and with that actually we have trained the model, and with that actually we got the results for that also. So this is actually very small data set. We also worked with the large data sets, but at present I don't have the results of that. So I thought that this is actually enough. For that is just understanding what is actually sentiment analysis, and how actually it will be helpful for the healthcare industry. So this is actually very sensitive information in the current scenario, because whether there is actually a big debate is going on whether we can just go for vaccine, or that is almost 95% people have adopted, but there is still a debate is going on, that is whether it is correct or not, whether we can accept it or not. There are so many tweets actually which is actually equally coming. Okay, so however, wherever you say that is highly positive comments are coming, that is negative comments also are coming. So we need to just how actually this is actually helpful. Whether this vaccine, it is not a problem, because 90% of the people are accepting, or 80% of the people are adopting for that. But take an example of something like some other issue. Take an example of some sort of political issue, or some sports issue, something like that. Some decision, somebody has to decide, or some decision making has to process is to be done by any individual, or majority of the people. Okay, if Rajnikant is voting for something, everybody will be, or something like majority voting will be for that. Like that, actually, this sentimental analysis, it gives a very it has a larger impact on the industry. So because wherever you go for survey, wherever the survey will be, the scores will be, it is again, it's nothing but it will be producing the results, the sentimental results, like the reviews, movie reviews, or anything, any reviews. Like if somebody is telling something, the some if review of a particular person is very important. Okay, so that means take an example of that Blue Satai Maran or anything. His reviews actually plays a very important role. So people will be just watching his review first, and after that will be that they'll be going and watching the movie. So same way, there are this sentimental analysis actually, like when you just go for a text information, it has actually it'll be producing some result that has a very big impact in the industry. Okay, and apart from that, I can just tell that this is actually this deep learning models are very much required for the sentimental analysis nowadays, because it will be giving better accuracy. And some of the that is concluding issues I just want to tell, that is it's a very powerful algorithm for the deep learning algorithms which is used for sentimental analysis are very powerful. So this can be just like improved for that, like this we have just considered for only text messages. We can just do it for images, audios, and so on. So the COVID-19 vaccine related tweets, like it is nothing, it can be extended still further for which is actually more relevant to health education, or business model related to health, social media analysis on health industry, so that we can just still predict, or still just understand the sentiments of the common public. So because the common public, or that is for whom actually we need to work a lot. Okay, their mindset, their that is because their mindset is very much required here. Their reviews and their comments are very much helpful for just for better improvement of any system. Take an example of you just take an example of Jipmer Hospital itself. Like there are thousands and thousands of people are every day they are just coming as patients. So the care can be improved, or a specific care can be a specific line of care can be better improved. So when it will be improved, when the general public gives reviews, or when general public gives reviews or comments, and that general public comments or reviews, when it is actually gathered together, with that actually with the gathered data we can't do anything. We need to first of all just go for a when we get 1 lakh data or 2 lakhs data, we need to go for a automated system. So this automated system again, it has actually larger impact. So we need to go for a sophisticated system. Sophisticated systems, that means the machine learning models and deep learning models. So this models definitely it has actually larger impact. So it will just correctly predict who actually when today I have just trained my model like that. Tomorrow's customer, tomorrow's patient, when he or she is coming, what is his expectation? I can able to satisfy that particular patient's needs. That is what actually expected now. Thank you. Any queries? Any queries?
Yes, madam. This is Srinivasan. The thing is, now, how can we do it for audio files actually? See, whenever if the audio streaming is more, here you are parsing CSV, right? So if we go for an audio file, probably it go for a pipelines. I mean, pipeline audios, pipeline streaming audios. How come we extract the information?
Sir, even for text information, we have lot of things. We may be just as we are text users, we say that this is actually very easy, but we are not comfortable with the audio files.
Okay.
Audio files again. We need to just go and study that clearly. Even I say that I can say that patient data sets. It's easy for me or to read, but
Okay.
there are so many hurdles there also.
Hmm.
When I say that, I'm just concluding that audio files can be used or emojis can be used. I need to first of all understand what is actually that input data set.
Okay. The thing is, no, ma'am. I mean, see, for example, the sentiment analysis for the stock exchange market, they are
Okay.
publishing all the data in Kafka clusters. I
Okay.
mean, it is also from by means of JSON values.
Mm.
See, for example, in each and every fraction of second now, the SAR value will be raising and it will be
Yes.
decreased. Based upon that, the users will be just, reacting about how to sell or how to, get it or whatever might be. So in that case, what can be, how can we do it? I mean, I think what is the exact technology what we can do it? Whether we can go it in a Go or Python or some other language we can do it, or which language will be quite suited for in this scenario?
You are telling about shares, which share to just
Yeah,
buy.
yeah, yes.
That
Actually, whether it is, I mean, Python is fine or Go is fine or some other.
Python itself is actually, I am just studying that one. That itself is actually giving better results.
Okay.
I'm not sure about others. Actually, I'm more comfortable with that. Actually, I'm just telling. Maybe actually it is actually depends on the perspective of the technical person who is using that. That gives better results. The thing is,
Okay.
only thing is we are not as of now. Even I can say, I can tell that 3 years back I was also not that much. Actually, I was not. Usually, will be taking from Kaggle and so on.
Okay.
I just did one work with Jitmar. Then only I came to know that is we need to first of all understand data first.
Mm. Yeah.
The data input, whatever anything, there is so many things that needs to be under. Only then we can just, because there are different models nowadays. By working with Python, it's very simple. Or any other tool, like I need another 1 day, I can tell, or I need another 2 days to train myself. So, but only thing is data set, whatever, what is our expectation, what is our result, what
Okay.
result our we want.
No, ma'am, actually, the thing is, no, my question is, see, if the data set is huge and if the frequency of data, I mean, publishing or subscribing is too vast in fraction of seconds, they are pumping I mean, bulk of data. I mean, bulk of data. Say it is coming in terms of, I mean, GBs and GBs of data. They are pumping it out. Whenever the market is on at around 9:45 in the morning, they are just giving the data in terms of, I mean, they are giving pumping it as in a high speed.
Okay.
How to, I mean, even though if we are doing in Kafka, the reaction of users might be differing, right? How to analyze the users? For example, I don't know, I think these guys, I mean, India Bulls and the other stock brokers, they are giving, by seeing the results, they are just I mean uh, I mean, advising the users of them to I mean, to buy this or to buy that, or all these things. So what I'm thinking in the sense, how much they are analyzing the data, I want to know about it actually.
They'll be having a pre-trained model.
Okay.
Even your Grow or any app you're using, they'll be having a pre-trained model.
Okay.
So
Is it all, they are also using the sentiment analysis, right, ma'am?
it can be anything, opinion mining, or we can give different names, but the concept it will be the same.
The same, yeah, yeah. Okay, ma'am. Thank you.
Yes.
Ma'am, I need a little clarification over here.
Yes.
Here, where you are talk about polarity score, no?
Mm.
So where that particular thing comes in picture, ma'am? Because, for example, if we have a text data set, we do, I mean, whatever things that you are talked about, we applied over there, and we'll got some feature extraction technique. We'll get feature from, we extract feature from those techniques, right? So
Mm.
after that, where we have applied polarity score and what is the use of it, and like it is a probability value, or what it is, and who is going to assign that value, and if that is changes upon application, or anything else, ma'am.
No, polarity score, let me just give
Just go to
example.
slide number 26, ma'am. 26.
26. Yes, I'm just here. Yeah. Okay. So now this one you're telling this slide.
Yes, ma'am. Yes.
Okay. So here the
Who is
sentiment
going to
score. Like
assign
take an
that?
example of yes, yes, yes.
Yes, ma'am. Yes.
This one itself, it is equivalent. Now, one second. The way like equivalent to polarity score. Like now you can tell we are just it is actually ranging from 0 to 4. But
That is a target class, no? If both
now
are same,
wait, 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 one second. So similar to this one, so every component, every sentiments will be having a score. Okay, which is
yes,
actually
no,
so
yes,
here.
ma'am.
So the thing, whatever you have asked is who decides this, and what
And
is
like how that polarity score knows like this particular sentence have more emphasis than this, something like that. If, for example, if we have some positive sentence means that have some, some probability value, no, in negative sentence like that. If some
sorry,
particular sentence,
Manikandan, something you told I couldn't able to hear. There was actually lag. Can you repeat?
no, ma'am. For example, in sentimental analysis, what our main intention is, we need to find out voice over that sentence, right? Positive, either positive, negative, or neutral, no?
Mm.
So,
Mm.
like in that sense, in that particular, like particular scenario, where
Mm.
this particular polarity score comes in picture, and what's the use of it, and who is going to assign that thing? It is like how to say, it is system generated, or we need to give something like that,
So
I'm
first of
asking.
all, we need to have a dictionary, or I can say that we need to assign. Suppose, take an example. I'm using a you have a Royal Enfield bike. Okay, you say that it is actually it is more comfortable for me. So comfortable will be having some score. Okay, so whenever just you have a set of words like which is actually specific set of words which will be having specific scores. So when you just when a new user, or when a new comment comes, so that definitely it will be having, so it is actually the set of already available scores, it will be pre-trained, it will be assigned already. So you have a dictionary, or you have actually a library, you'll be having a model which actually assigns polarity for everything.
Okay, ma'am. Okay,
Mhm.
fine, ma'am. Thank you, ma'am.
Thank you.
That was an outstanding session, ma'am. Thank you so much. If there
Thank you.
aren't any doubts, participants are requested to fill the feedback form. Thank you, ma'am.
Thank you. Shall I close the session?
Yes, ma'am.
Thank you so much, Prashanti.
Thank you, ma'am.
Thank you, participants, for just having or just interacting with that is with me over the session. I hope it will be helpful for all the people, all the participants present here. Thank you, Jay Shimal. Thank. I also thank the HOD and Manikandan for
Thank you,
giving this
ma'am.
opportunity. Yes, thank you, ma'am.
Thank you, ma'am. Thank you, ma'am. It was
Thank you.
really an outstanding session, ma'am. Thank you. Thank you so
Thank
much.
you so much, Manikandan.
Thank you. Thank you, ma'am. Thank you.
Thank you, Srinivasan sir.
Ma'am, good morning, ma'am. Uma, ma'am.
Yes, yes, I'm here.
Good morning, ma'am.
Good morning. Good morning.